part of this section is probably review for many of you, but it does expand on some topics which every algebra student should know about. So we probably will learn a few new things here that are important. Anyway, we start off with a quick review of radicals, and here's one. Now, what would you call that? So it's called the square root of 49. And what is the square root of 49? It's going to be 7, since 7 to the second power, or 7 squared, equals 49. So, square root of 49, again, it's 7 because 7 squared is 49. When you look at that, you see the square root is sort of an opposite type of operation from squaring. And indeed it is. It's called an inverse operation. Now here's another type of radical. And I'm going to describe this as the cube root of 125, or the third root of 125. And what is that? That ends up being 5, since 5 raised to the third power is 125. So there again you see this sort of oppositeness of operations here. The opposite of raising a number to the third power would be to take its cube root, or third root. So the third root, cube root 125, is 5. These, this little number I wrote here is known as the index of the radical. So this is the index. And it's important to look for that because that describes what kind of radical you have. Now, many students verbally tell me this is radical 49, but please be careful with the language there because there's a difference between this radical 49 and, say, this radical 49. All right, so here the index is 5. It means it's the fifth root of 49. And it's some decimal number. I don't know what it is. We could look it up or punch it up on a calculator. But it's a different number than this radical 49. So I would really encourage you to get out of the habit of using the word radical in labeling a number. Okay, the word radical describes the sign that we're using. But you should use the word roots to specify. All right, so why do we call that square root? For one thing, well, of course it comes from squaring this number, but it too has an index, and the index is 2, number 2. But it's traditional not to write the index of 2 on square roots, just out of convenience, since they're so common that when it's blank it's understood to be a 2 there, a second root. So we could call this the second root of 49, we could call this the third root of 125. All right, well, another thing I'd like to talk about here, and let me erase this and go back to this assertion, since 7 squared is equal to positive 49. Well, why wouldn't negative 7 be a square root of 49? Because if you raise that number to the second power, you also get positive 49. So why is it the square root, and I'll raise the little 2 here, why is it the square root of 49 equal to negative 7? Well, it is. It's one of the 2 square roots of 49. And so all numbers except for number 0 have 2 distinct square roots, a positive and a negative. But here it gets a little technical, because when we use the square root sign, or the radical sign, we, by convention, we declare this to be a positive number. And so the square root is always a positive number, or there's an exception with 0. Square root of 0 is 0. But square roots are defined to be positives. So it would be false to say that the square root of 49 is equal to negative 7. Okay, that's wrong usage of these symbols. You might wonder why would we make up such a rule? And this really is, a man-made rule, how we define this square root sign. And it's for a good reason. You may recall back from an early chapter in this course discussing functions. And a function is a mathematical relation in which for every input there is a single output. And so to say that the square root of 49 is equal to both 7 and -7 would be to give the square root function two outputs. And with two outputs, it would no longer be a function. So for that reason alone, I believe is why we always define the square root. We disagree it's going to be a positive number. So it don't mean for this to be confusing. We would say that -7 is the negative square root of 49. So -7 is the negative square root. I'm going to abbreviate here, square root of 49. And 7 is the positive or principal square root of 49. So, put my period there. We label these, and when we apply the square root, we're only going to get a single output, so we use the principal or positive square root. All right, so that's an important consideration. Now, if we want to represent -7 as a square root of 49, then we'll just have to put a negative in front of the square root sign. And that would do it. So this is how we can represent a negative square root, is by, again, having the negative on the outside of the square root. So there we go. The names for these, in case you've wondered further, if you had a square which measured, for example, 64 square feet, and I'm going to represent that as feet to the second power. So in other words, if this thing was large enough so that there were 64 squares, each a foot on a side, inside this area, and it wouldn't necessarily have to be a square to have that area, but if it was square with that area, then the square root of 64 describes the dimension of this square. So it's 8 feet on the side, since the square root of 64 feet squared is 8 feet. All right. Well, the same would go for cubes. If you had a cube which contained 216 boxes, all the same size, then the length on one side would be 6. That would be the cube root of 216. So 216 boxes inside, 216 cubic feet, for example. The length of the side of the cube is the cube root. So those were the terms square and cube all come from. It's from geometry. We can have of course, other kinds of radicals. And in fact, an important one, which I may talk about later, is the 12th root of 2. So the 12th root of 2, why is that important? Well, it happens to be the number in which musical notes are tuned on keyboards. And so it's a ratio that's used in tuning. It's been used since around the year 1720, give or take. But I may talk about that later. This is approximately 1.05946. But radicals play a big role in algebra, and in our physical world, we're mainly concerned with square roots and cube roots, since we live in a two-dimensional or three-dimensional world, depending upon how we're looking at it. But occasionally we have need for higher order radicals. Finally, one last note, the word radical was a term associated with these operations. Back in the 1960s, when I was young, the term radical became to be used for, or commonly was used for, someone who wanted to drastically reform or change society. And that's still used today. A person who is radical in some kind of ideology has more extreme beliefs. But it takes its term from the mathematics. A radical sign changes a number to a different form. And so a radical in society wants to change society. So that's where how that term got to be used in plain English in a non-mathematical way.